Thanks everybody for coming to our Smart Connectivity and Operational AI panel. I'm very, very honored to have a very large, diverse, and very interesting group of experts in a very specific field that is tied to connectivity. We have a tendency to overestimate the simplicity of connectivity as basic humans and people that have cell phones and computers. We think Wi-Fi is great, even though it's the first thing that we like to complain about. But this panel, this group of folks have been in the industry for many, many years, some more recent. And what we're seeing happen in our industry is a complete democratization of telecom infrastructure. The ability for enterprises, companies, airports, ports, hospitals, hotels like this one, to now have access to technology that was only available to the few, to leverage, to be able to understand how people, places, and things are generating data from the physical world, and how that data can be used to improve their businesses. Everything from supply chain, to safety, to security, to compliance. And this group of panelists have all examples of technologies that they're involved with that are part of the PwC ecosystem that we take to market to solve problems for our clients within our connected solutions and our connected physical space, our operations space. So with that, there's a very large group of people. We figured if everybody talks 10 minutes, we've got the whole hour. Hopefully, we'll make this a bit more interactive. But I've asked everybody to do a quick 2-minute introduction, and we'll start with Alper all the way at the end. If you just tell us who you are, what you do, and we'll start there.
Good morning, everyone. Thanks for coming. My name is Alper Yegin. I'm the CEO of LoRa Alliance. LoRa Alliance is an international nonprofit technology association formed to build and promote adoption of LoRaWAN technology. LoRaWAN is a wireless communication technology. It's long range, low power, using unlicensed band, and it's specifically built for the Internet of Things use cases, spanning all 7 verticals: smart cities, smart buildings, smart home, agriculture, industry, tracking, and utilities. Today, there are nearly 100 million LoRaWAN devices deployed all around the world, and our largest networks are seeing 50% CAGR. So the deployments are speeding up. And we have nearly 400 members of the LoRa Alliance. I hope to see more of you joining LoRa Alliance as well. Thank you.
Good morning, everyone. Thank you for hosting this, and the mimosas were a nice touch this morning as well. I'm Apoorva Nori. I'm head of product for Hubble Network. We are a Seattle-based company connecting off-the-shelf Bluetooth devices directly to our satellites. So asset tracking tags, remote sensing devices, industrial monitoring devices, all with just a software update connecting directly with our satellites in the low Earth orbit. So March of last year, we launched our first 3 satellites. We've got another launch coming up this year, but yeah, we really hope that getting smaller, simpler, more rudimentary on the end device side just makes the sort of connectivity that we're talking about all the more accessible. So
who knew you could do Bluetooth from space? Anybody know that? So you learned something already. That's awesome. Thank you, Apoorva. Speaking of Bluetooth, Neville?
Neville Mayers. I'm the CEO of Bluetooth SIG, which is the global organization that sets standards for Bluetooth. The Bluetooth SIG itself is a very interesting organization. We do way more than just standard setting. We're a trade organization, so anything that is standardized, we promote and drive a better understanding of so that we can get a broader adoption. We are an IP licensing organization. So actually we administer and maintain the largest cross-license IP pool in the world. We have 45,000 members who essentially sign up to a cross-license IP agreement. So that's pretty amazing. We do standard setting, of course, and every year we're involved in releasing a number of different standings. And at any point in time, we have about 50 standards that are in development, different types of standards. And our most recent one was channel sounding, which allows devices to basically have centimeter accuracy in terms of distance proximity measurements. When I think about Bluetooth and I think about the environment in which we operate, our members ship or will ship this year about 6 billion devices that have Bluetooth. And the IC manufacturers will integrate about 8 billion Bluetooth instantiations into their chipsets. Many different products have multiple Bluetooth devices or ICs. Most of those, everybody is familiar with audio, Bluetooth audio and consumer electronic devices. But about 1 billion of those devices are actually going into industrial and commercial markets. So if you think of electronic shelf labels, if you think of sensors, if you think of the smart home, all of those places consume Bluetooth LE devices. And so it's a huge ecosystem that has been created across the globe. And the one thing that I really wanted, the reason why I joined the Bluetooth SIG, and I've been with them for 7 months, is I really believe in this idea of networking and the notion that Bluetooth is not an island into itself. It's actually part of a much broader ecosystem. And so working with a diverse set of players out there is really important. So whether it's LoRa, or whether it's Wi-Fi, or whether it's the Connected Car Alliance, or whether it's CSA, we all need to come together, including 3GPP, and create an ecosystem that is best placed for our customers.
Thanks, Evelyn. And SIG stands for Special Interest Group. So
Special
we're all
interest group.
part of a special interest group just being here. Thank you so much. Alan?
Well, thanks, Patrick. Good morning. I'm Alan Proethus. I'm the CEO of GXC, and we provide turnkey private 5G networks for industry and enterprise. And so my background is heavy in IoT connected solutions for many, many years. And so this is just the high data view of the world for connected solutions, whether it's enabling all kinds of enterprise campuses. So GXC is originally a spin-out from the University of Texas. We were backed by people like Intel Capital, BMW Ventures, Rain. Actually, just sold the company 2 months ago to one of our big investors, and we'll talk about that, some of those use cases. But really, our focus is providing a turnkey system. And if you think about how people buy enterprise Wi-Fi, you don't buy a radio one place and then buy software to run it in a different place. You never get anything done, right? And so we've taken that integrated approach with a turnkey private 5G system, really focused on things like the biggest chicken and beef producer in the world, the biggest chemical company in the US, some of the biggest agriculture companies and biggest warehousing logistics companies, because I think every technology has its place, and the trick is using the right tool for the right job in every situation. So we'll talk about some of those exciting use cases in just a minute.
Thanks. Azita?
Yes, hi. My name is Azita Arvani, and I've been in the telecom and connectivity world since the 2G days, where we had 9.6 kilobits per second. And now, of course, we have over 1 gigabits per second, like 100,000 times faster. We started when data was really not there. We couldn't even text from AT&T to T-Mobile customers, if you remember those days. But now, a lot of consumer applications now and enterprise applications and so forth. So I've been doing a lot of things on various parts of the stack, from the application layer to the infrastructure layer. Been with a lot of big companies, like worked with Docomo and Nokia and Rakuten Symphony, where I was the CEO of Americas. At Rakuten Symphony, we brought in sort of new way of doing telecom infrastructure for 4G and 5G, with cloud native, open RAN, and automated network, which was like a digital transformation for telcos. Now, I believe that digital transformation for any business includes at least 4 sort of technology transitions. One is AI, the other is cloud, IoT, and networking. Networking is a big piece of that. And AI and networking have a very symbiotic relationship with each other. AI obviously can be leveraged for any industry. So we have AI for telecom, but telecom networking of all sorts that we see here, and including cellular, can also help with AI, and that's the area that I'm focusing on right now. And I really look forward to the discussion.
Thank you. Sanjita?
Yeah, good morning, everyone. Sanjita Shamsundar, thanks for coming out. I know, early morning, and the mimosas are helping. So, or not. I stayed away from it, so. I am the CEO of a company called NextNav. At NextNav, what we do today is a backup to GPS. And all of us take GPS and location for granted. If you remember, maybe 10, 15, 20 years ago, location was not a primary usage in the mobile. The GPS satellites were built by the US government for military applications, and then I think President Clinton made it available to consumers, and now our entire economy is dependent on location. $1 billion per day loss if GPS doesn't work, it turns out, right? Because tracking, and of course maps, we take it for granted. People say, hey, I have Google Maps, how come location is not working? But people don't realize that that is powered by GPS in the background, right? So indoor doesn't work. Try finding your way inside this maze. You can do location.
We solved for that, but we can talk about it.
No, it hasn't been solved. in pieces. It's very fragmented. It's fragmented, yes. But the most important thing to know is that GPS as a national security and a national resilience, if you look at it, it gets spoofed and it gets jammed, and we need alternatives. We need backups to this important component. So we at NextNav are looking to build a terrestrial GPS, terrestrial backup to location, PNT, position, navigation, and timing. Timing, turns out, is also coming from GPS, and everything, all the critical banking and infrastructure, financial depend on that. But what is important to know is that we cannot monetize location today. Location is free,
That's right.
Powered by the US government, right? So then how do we solve this problem? Turns out the recent 5G standards have something like a GPS signal embedded in them that you can utilize. So you can use the same network to do both location as well as data. And we are working with the FCC to make changes to the 900 megahertz band that we have to be able to do that, so that you can use the network for 5G, and then location is a part of that solution.
So it's interesting. So of all of you, and it's interesting that there's no wireless operator on the panel, even though we're talking about the future of connectivity.
At one before,
I know we were all involved somehow. We like them very much. But what we're seeing happen with this democratization of telecom infrastructure is these plethora of applications that are beyond just connectivity from a kilobits per second standpoint, right? We all have SIM cards in our phones. We all pay whatever we pay per month. There's a capacity. We're not going to start watching Netflix faster, right? We're not going to pay more for what we're paying today for our connectivity from our service providers. But in the enterprise, we're seeing an explosion of use cases with a lot of the technologies that you guys are talking about, where location is critical, but also context in which a person, a place, or a thing finds itself in, right? Whether it's for asset tracking, whether it's be able to monitor the crowds or the occupancy of this room, whether a door is open, whether a door is closed. And a lot of the technologies that you're talking about have low latency and high speed, but also very sensory type technologies, and they're all generating data. And this is time series data that is tied to an operation. Every business is going to start getting this new type of data set, which is going to do what? It's going to feed the AI, as Ida was talking about, right? And so where do you guys see the market evolving, particularly in the enterprise space? Because we're all, it's interesting that Neville says, Bluetooth is known as a consumer electronics technology. Well, in fact, it's very much embedded. A lot of the devices that you'll see that are part of our ecosystem leverage Bluetooth in some way, shape, or form, as well as LoRaWAN. We're essentially a big LPWAN network here in the United States as a result of our relationship with Sigfox that Alan was involved in. And we can talk about that. We have Alec and and Brian here, and Sophia, and Bikram, and Stephen from our Connected Solutions team. And welcome for you guys to chat more about what we've been doing in this space. But how do you see, Alan, the market taking off around the enterprise space, and what are some of the key applications that you're seeing with the LoRa Alliance?
You know, it's funny in that as an IoT refugee, you know, we've been talking about this stuff for a long time. And, you know, full disclosure, I was the founding president of Sigfox North America, so I built a low data network covering 70 million people. I put together a large joint venture with Sony for IoT and ran it as chairman. And the whole premise of this was you need data to do stuff with, right? It's as simple as that. And, you know, it's really hard to get the data, and it's really hard to actually do stuff with it, although it's been getting better over time. So you think about what is AI? It's about using hordes of data to make better decisions. And the big three of IoT have always described as either generate more revenue, cut costs, or regulatory compliance. And so to me, there is no better match in the world than sort of taking what we've been trying to do with IoT and now applying AI to it, because you're going to get better insights faster. It's the whole point of what we've been trying to do all these years.
Alper, you want to talk a little bit about some of the applications, in particular Starbucks, that you were mentioning earlier?
Sure. So regarding LoRaWAN, because the technology is using unlicensed band and it's very low cost in terms of building networks like the base station prices, moving downward towards the Wi-Fi access points, indoor and outdoor, the technology is highly accessible. And through that, now we see LoRaWAN deployed as public networks. We have multiple nationwide networks like Orange in France, Swisscom in Switzerland, KPN Netherlands. They have nationwide networks, public ones. And then we see private networks being deployed, and I'll dive into that. And then we also see community networks being built, like the Helium with 500,000 base stations all around the world. Not only terrestrially, but also in satellite-based. We have 3 operators providing connectivity through satellites. One of them is geo-based, EchoStar Mobile, providing pan-European and pan-North American coverage, and also 2 LEO satellites, Plan S and Lacuna. Now, speaking of democratization, through this accessibility, we see the LoRaWAN network sprouting all around the world. And nowadays, the largest momentum we have is with the private networks, the enterprise networks. So what does it provide for the private enterprises? Again, low-cost network and good penetration. So what gets you the ability to reach low Earth orbiting satellites around 600 kilometers? When you put the base stations inside the buildings, they start piercing through the walls and the metallic obstacles. And that's how people can now build indoor gateways at a very low cost and still enjoy the low power nature of the sensors. So the Starbucks example is, in a typical Starbucks store, there are 12 places they store the food, and they have temperature sensors. In an average Starbucks store, an employee has to spend 25 minutes a day recording the temperature readings. And that's just time wasted that could have gone to the customer satisfaction, right? Now there are more than 10,000 Starbucks stores in North America that deployed LoRaWAN gateways. Every one of them having a single LoRaWAN gateway, enabling the cold chain monitoring. And that's the 25 minutes now that can go to the customer satisfaction and other practices. And Starbucks is not alone in doing so. There are other brands in the US as well, like Chick-fil-A, McDonald's, Shake Shack, Hard Rock Cafe. They have also deployed LoRaWAN for similar use cases. And having started with the cold chain monitoring, it's really easy for them to add other use cases like air quality monitoring, leak detection, energy monitoring, things like that. And also a recent news is that AT&T also started providing LoRaWAN-based facility management service called Connected Spaces. So we are seeing more and more companies coming on board, providing this facility management across US and abroad as well.
Purva and Neville, you guys are in the BLE space. What are you seeing on the enterprise side where BLE is being used? And I imagine asset tracking obviously is the one, but are there others that you're seeing as well?
Yeah, absolutely. I think sensing applications, just like the ones that Alper was describing, we see that same sort of interest with Bluetooth devices, right? I think what a lot of people are finding and what I'm seeing in the enterprise space, I think a lot of us may be observing this too, is end devices are getting more and more mobile. They're no longer static or fixed to one store or one retail environment. They're moving globally sometimes. And also, a lot of enterprises want to get smaller and smaller in terms of what they're tracking and monitoring just to get those intelligent analytics. Now that you have the power of AI sort of helping them with their operations, right? So when you move smaller and smaller and get faster and faster, that asks networks to be a lot more dynamic and performant in order to keep up with what are becoming more rudimentary end devices, right? You're no longer able to put an $80, $200 tracking device on a $50 power tool. The economics of that wouldn't make sense. But if you could use something as ubiquitous as a Bluetooth chip, which in many cases is already in a power tool, to actually get global connectivity with that device alone, that sort of changes the dynamics. It means you can actually get very granular and small in terms of
What's the
what
price
you're
point
managing.
that you guys are looking at for the actual chip that's doing the asset tracking?
Well, yeah, but Bluetooth SIG expert here can give us the prices
okay.
on Bluetooth chips, but
We don't talk about pricing.
It's like Fight Club.
It's cheap.
Let me just say, it's low.
It's
right?
not about the price, it's about the value, right?
Exactly.
Yeah. I've heard that one before.
Yeah.
Anyway. No, for sure. I mean, clearly, but are you seeing, Neville, people within the SIG that are more just basic enterprise folks that are showing up as opposed to the typical consumer electronic? I mean, we're at the Consumer Electronics Show,
Sure.
but
Yeah.
what we're seeing is that it's becoming the technology show, right? I
Yeah,
mean,
yeah.
we have a lot of our customers are now coming to CES to find out what's next. And I know you guys have some interesting announcements that you've been making as well for the enterprise space.
Yeah, in 2000, let me start with, back in the day, in 2010, when Bluetooth LE was first introduced, the whole premise was low power. Actually build a device that is wireless, that it enables communication, that can run on a battery for many, many years. And so you saw BLE going into multiple devices, into sensors, and propagating out into the market. In 2017, the Bluetooth SIG standardized around a mesh protocol that essentially allowed thousands of devices to connect to a hub and communicate with that hub and report on data and actually be controlled. And that resulted in this enterprise lighting system being developed, which is now a standard across the globe, where if you go and deploy enterprise lighting, you deployed with a Bluetooth network lighting control system built in. And that has resulted in up to 70% energy savings within buildings. That is now being evolved into HVAC controls. And so you can now, based on human occupancy, control how much energy you need to extract out of buildings to keep them a certain temperature. So we see the enterprise evolving over time into these systems. In 2023, a new standard called PAWR, which is Periodic Advertising with Response, was launched, which essentially allows electronic shelf labels to periodically communicate with a hub that can support tens of thousands of devices. And so, recently Walmart announced they're moving towards this now standardized ESL technology. They don't have to rely now on one supplier. Multiple suppliers, because it's a standard, can supply them with the electronic shelf labels. That's good for their supply chains. It's good for their, for the consumer. They can actually just display using e-ink information about pricing, real-time pricing as their supply chains bring in the goods. And so Bluetooth is actually helping transform the way things evolve within the enterprise and within supply chain. A little later, I'll talk about what we're looking at in terms of the next big thing for Bluetooth, but that's going to radically change supply chain management.
We'll save that for later. Alan, you were in the sort of LPWAN, we're talking low bandwidth applications around sensory technologies that in some cases require private, in some cases don't. We now even have a satellite provider in the Bluetooth world. What made you jump to GXC and is everybody familiar with CBRS, which is the notion of spectrum that's being allocated for private use? So basically, if you're a hospital, a hotel, an airport, or a university campus, you now have the ability to build your own private cellular network, and that's what GXC's business is. And it's providing a huge opportunity for new applications around the enterprise that goes beyond just being able to do roaming onto that property from AT&T, Verizon, and T-Mobile. What are you seeing happen? And first of all, what made you make that jump into the private cellular world, and how do you see that world evolving?
Well, it's just it's the other side of the coin, right? You need both, and it's not any less love in my heart for LPWAN. But in fact, we often are the backbone network for LPWAN. But if you look at what's going on with AI, and let's take autonomous, there's been a lot of autonomous activity. And you don't have autonomous without AI. You're now talking about big data. Okay, for instance, we have a customer in Q4 who does semi-autonomous construction equipment. They basically take a magic box they created, stick it on top of a pile driver or a bulldozer, whatever it is, and all of a sudden, these things are just doing their thing. Okay, but a remote operator has to take control once in a while because they get stuck because they're smart, but they're not that smart. Okay, think of like a young puppy. But so they tried putting out like 20, 25 Wi-Fi access points, and it's not that Wi-Fi is bad. We all need Wi-Fi in many places, but every technology has its specialty, what it's good for. And we were able, with 2 to 3 private cellular nodes, provide complete coverage, super low latency, no dropping, and all of a sudden, security, because you don't want someone taking control of that and having a killdozer running around town, right? But with just 2 or 3 cellular nodes, and now they're deploying, we literally deployed, I think 8 or 10 sites just in Q4, and they're doing dozens and dozens this year. And you literally can't do what they want to do with autonomous without this kind of high data, very secure network. So I would describe it as everything has its place. And the other thing is, we announced a partnership with Dell and Intel in October that we are their private cellular partner for Edge AI. And it's the same problem where you have this massive data you need to even begin to do the AI stuff that's, we all see the commercials about, right? But if you can't get the data, you can't do anything.
So you mentioned, that's the key thing, right? It's all about the context in which the person, the place, or the thing finds itself in, and how that data could be leveraged with AI to make the world a better place. But when it comes to the actual applications that you're seeing in this private cellular world, we don't have robots everywhere yet. We know they're coming, and you certainly don't want to connect your robot to a Wi-Fi network because it can't do handovers, right? I mean, that's going to be a problem if it's moving around. But what are some of the first sort of key applications you're seeing in the enterprise space for private cellular?
So in addition to autonomous outside, one of the main reasons we were acquired 2 months ago was by this company, Motive, that most of you probably never heard of. It's a $500 million a year revenue company in Orange County, California, not near the fires. And they are in 17,000 warehouses and industrial buildings. And they do the batteries that go in forklifts, they do the charging systems, and a lot of the renewable. The number one request they're getting from their customers is, how do we automate everything? And Wall Street Journal just had an article on Friday about 100+ deaths a year from forklifts. The actual injury rate, I think, is more like 5,000 a year. And so one of the key use cases now is how we're now just going crazy with, how do we help automate everything in that warehouse, everything in that manufacturing site? It starts inside the building. It starts with maybe simple things like forklifts. But frankly, it also is, hey, I need to do inventory on this tablet. And the last thing I want to do is be on a Wi-Fi network in a part of a building, and then I walk outside for overflow, and now I have to go VPN on a public cellular network, if it exists. And now I go in the next building, and now I have to go on some kind of private network where I maybe have coverage. And how do I pull all this together in a very secure, seamless manner? And so again, not one thing solves every problem, but that's what's driving these private cellular networks. And I think it's also, as a result of this, going to drive more BLE, more LPWAN, with LoRa, because you need all these little pieces then to come together. And really, the system integration is the big gap.
Azita, we talked yesterday about AI in the network, AI for the operators, but is the AI that you're seeing in your space and in your ecosystem, is it tied to the network itself and the connectivity and how it could improve efficiencies? And we talked about self-healing networks last night at dinner. Or do you see it being on the back end as a result of the data that's being acquired from these networks and leveraging that as part of an AI deployment?
That's a great question. I just wanted to add something to what Alan said, because I'm on the board of a company that develops and manufactures cleaning, industrial and commercial cleaning machines. Like when you go to the airports, you see these big sweepers and stuff that clean and now the new product lines are autonomous, right? And for connectivity, we are using cellular. Because of all the things that you said, that you're in an airport or something, you don't want to have gaps in the coverage. You want to have enough capacity to be able to take the data out for security reasons, for operational reasons, for efficiencies, preventive maintenance, all of that. So it's actually I totally agree with you that you have a kind of a hybrid of things, networks going on. When you're developing your devices. Some of them need cellular, some of them need LoRa, some of them Bluetooth, and some like a combination of all of that. I was recently at a sports arena, Intuit Dome, for those of you NBA fans, Clippers has a new sports arena, and everything that could be connected was connected, right? So we're talking about leakages, talking about like cameras everywhere, like when you go buy your hot dogs, there's no person actually selling it to you. It's kind of like Amazon Go stores everywhere. But not everything is connected via 5G, right? Certain things that need lots of throughput, high speed, they're connected on 5G. But things that, like for pipe leaks and things of that nature, they're connected with much lower cost type of connectivity solution. So I think in a practical sense, a network, especially in a big complex place like a sports arena, is going to be a combination of connectivity devices. If I may go back to your questions about AI, I think we all know sort of like the future of our world is about ubiquitous intelligence, right? So we're AI kind of everywhere. But that AI everywhere has to be supported by ubiquitous compute, right? And the data that's coming from our devices, sensors, et cetera. So where is that ubiquitous compute? Right now we're thinking about, okay, we have the central cloud, and then we have like our device AI, right? And I believe that networking can play a big role because it creates different edges, not just the very far edge, not the very central, but multiple edges in the middle that can help bring in that compute.
I mean, do you all believe that with these private networks that the enterprises that are deploying these solutions are going to therefore have an increased need in terms of capacity for compute, but also the impact on the energy, right? We all love this world of LLMs and what they're doing to I know we're spending a lot of time with our clients helping them understand the impact that that's going to have on their businesses, and the impacts are astronomical. But the other impact is on energy consumption, right? I mean, where do you see connectivity potentially coming in and supporting a more sustainable world as it relates to these new technologies? So we don't want to be telling all of our clients, oh, deploy this, deploy that, and all of a sudden your carbon footprint is going through the roof and your costs are going through the roof.
For every one cellular access point you need outside, you need 10 Wi-Fi. And indoors, it's 4 to 1. And so what happens is, it's not the Wi-Fi is bad, it's just that its scale, it's not sustainable. You can't do broad coverage very easily. And just the maintenance and operational support. Because the other thing we're seeing, we thought a lot of these Fortune 500 companies were like, oh yeah, we'll manage this network, we manage stuff, yeah, what's the big deal? They're like, oh, cellular, it's black magic. We're not, especially because it's tied to an application. And so, I think, we didn't get into the prediction part, but one of my predictions for 2025, the number one opportunity, coming from an IoT background, I think managed connectivity together with the application is one of the best things you can do. And then throw on top of that the multi-network managed connectivity with managed applications is the number one opportunity in the new year.
And to build on what Alan was saying, in addition to that kind of efficiency with the power, but you could also take the the telecom, the sort of connectivity infrastructure, the CPUs that are using for like your basebands and things, and you could share it with AI. So you're not bringing two different compute infrastructure.
It's all NVIDIA, is what
It's
you're
all like integrated. No, it's all integrated AI. And but you know, at least for the short term, I think it's a CPU GPU combo. And of course, if it was you know, NVIDIA would envision it as all GPU.
Vishal's in the room. He's looking at his
just make
phone.
a
We've got
point.
Intel in the room as well, so it's not just NVIDIA.
With respect to AI and the huge amount of energy that you speak about, think about networks, Bluetooth being part of that, as the neural system, the central neural system of an enterprise or a factory, collecting data, pushing it out to the cloud, using AI to analyze that data, and then pushing back algorithms and actionable insights back into the network. Initially, you may want to train the AI engine on what's happening, but over time, you will reach equilibrium where you're not actually bringing a lot of compute back into those environments. So I think you're going to have these learnings, and it started with machine learning. Machine learning is a part of AI. It's the first instantiation of AI. It'll get smarter over time, but at the end of the day, I don't believe that you're going to have within these enterprises a huge amount of compute power over time driving AI, operational AI.
Yeah, I mean, I think I agree, but then you also look at a continuum, right? For high-cost devices like our smartphones, there's going to be a lot more inference and perhaps even some level of training. Qualcomm is talking about a billion plus parameter models on the device. But then when we look at like the low cost that we are talking about, that's not sustainable. Right? You will have some intelligence in the device, local inference, perhaps even in today, earbuds have some of that already, right? So there'll be some, but then we are talking about large amounts of data in an industrial setting. I think there is, we talk about edges, different edges.
Yeah.
Maybe there is an opportunity for an edge box on-prem that can do a lot of the heavy lift
Sounds like
already.
a new startup that we should think about.
Well, I think we're talking about edge for a long time,
Yeah.
and this may be at the time that it
And we've got satellites, so that's
That too, right?
different worlds. But so when we talk about this new operational data, because everything you're talking about is generating new data sets, new time series data sets, right? That typically AI will look at over time, and you'll detect anomalies and see patterns. And then to your point, Neville, maybe these algorithms could be used, say, like, this is what a hospital is supposed to look like, and from an operations standpoint, and then use that as a benchmark to compare to another hospital or a hotel or a restaurant in the case of your examples, Alper. So where do you see that data being computed? I mean, God knows, the big cloud companies are excited about this, right? Some of them are even in the LPWAN business. I mean, Amazon has Sidewalk. Do you see that coming back into the enterprise, or do you still see just more data going into the cloud as it relates to these private networks that are being built? I don't know, Alper, if you want to take that question first.
So in our case, actually, we see AI being placed in various places, all the way deep to run on the sensors. For example, a camera or a vibration sensor cannot transmit all the data over LoRaWAN, because LoRaWAN using the unlicensed band, there are limitations on the amount of traffic we can push. A given LoRaWAN sensor can push kilobytes of data per day, but not megabytes, not gigabytes. So for those kind of sensors, the AI algorithms are running on the sensor, processing the image, processing the vibration, and only sending the event triggers.
You can even take the pictures. So we have a utility meter that takes a picture of old meters, gas meters, water meter, electric meters, and it takes the picture of the data and it computes it in the device. It's a very small chip that costs $15. Yeah. And then you use an LPWAN network to send the data back. So you're not having to send a picture all the way back to the cloud where you're computing what the device is seeing or streaming the data, to your point.
Right.
So those types of, that's real edge computing.
Exactly, all the way down to the sensor itself, also like counting people in a retail store and only sending the count, right? And then one step upward, we also have deployments where The network and the application server are all bundled in a single unit. It's the base station, it's the network core network, it's the application server, and the algorithms are running on that. Again, the data doesn't go all the way up to the cloud for privacy reasons or latency and all that. Yeah. That's the second step. And then third is obviously we dump the data to the cloud and then some algorithms run on that. So we see all these three different types being deployed with LoRaWAN today.
You're actually going to see, what you're going to see, I think, is think about cloud, hypercloud providers. Basically, they have an infinite amount of services you can apply to the data once they get the data. So their whole point in life is to be the world's biggest shop vac of data, okay? That whole announcement I mentioned about Dell Intel in October, and you'll see many other people doing this with edge compute, because you can't afford to send all this data to the cloud out of the box. You know, so you're going to see more and more of sort of microservices offered on the edge at a central point, and then you decide what you're going to consolidate at a higher level. But it's the natural progression of this.
AI is probably the one making that decision, right? You say
Yeah,
you,
exactly.
but it's probably going to be some algorithm.
I think that's a practical way to do it, right? I mean, that's why we have different forms of connectivity, different bandwidths that needed, different. But then NVIDIA yesterday announced also a smart, or a desktop, right? So that's going to do it as well. So even NVIDIA is also talking about not just cloud-based, but at the edge as well.
The cost of the energy might go up, but the cost of compute is going way down.
Right,
So ultimately,
right.
it's a wash.
It may be your own cloud instantiation. And if I think about the next generation of Bluetooth and the next evolution for Bluetooth, there's a couple of companies out there actually implementing it today, but ambient IoT could run into billions and billions.
Are you thinking Wiliot?
I'm thinking of Wiliot, but ambient IoT, basically, if you take a very, very, very low-cost Bluetooth LE device and you pair it with a PMIC that does energy harvesting, either light, movement, harvesting of RF frequency, you can create a sub-20-cent sticker that you can place on any object and get temperature, humidity, light sensitivity, and location from that device. This is an RFID replacement. There's no active scanning. You're basically these BLE devices.
And we're all the network too, right? Because all our phones are detecting.
All the network.
Feeding that back into the system.
And these devices chirp out once they have a capacitor that harvests the energy. Once that capacitor is full, it chirps out where the location is. You can imagine, at that cost point, just the types of implementations that could be used. So Wiliot is trying to disrupt supply chains and using this tag. Their first customer is Royal Mail. Royal Mail is basically going to track all of their parcel containers where they put all the parcels and push them into trucks and then ship them to different depots. They're using these tags to actually track all of those containers around the UK. But Wiliot has created this AI engine. You can imagine the amount of data coming from millions of these devices. For example, the example that they use is if you want to track a commodity that has a shelf life, or a medicine that is sensitive to temperature, you want to be able to track it from source all the way through to the consumer purchasing that device. That whole supply chain length, if you're using this Bluetooth LE tag, you can actually look at all of this data along that supply chain.
Even aftermarket, even once it's in the house, right?
I'll get to the aftermarket, but you're pushing all of that information into the cloud. A human doesn't have the capability to analyze that data. So you push it through an AI engine to get these actionable insights. And what they've then done is paired that with a natural language engine, AI engine. So you as a consumer, you go to the supermarket, you look at the shrimp that's in the cold section, you scan this QR code that sits on top of this Bluetooth LE label, and you now open up an app, and you can talk to that app in natural language and say, okay, how many times was the shrimp below X temperature? Is this shrimp still safe to eat? Should I buy it? If I do buy it, how long can I keep it for? Yeah. And so you can get all of these insights based on all of this data that has been collected along the supply chain. So supply chain integrity and optimization is a huge opportunity for Bluetooth.
But in this case,
using
and
AI.
we've been working with Wiliot for years now, and it is a closed system, right? You need the key. You need to. They won't just make it available for everybody, and maybe they will at some point because it's a commercial decision.
It's going to be. It is going to be ambient IoT is going to be standardized
As part of 6G, right? As part of the next standard for.
as part of Bluetooth.
As part of Bluetooth.
Not 6G.
We have John Hoffman, who's just joined us, the CEO of the GSMA. It's a big wireless happy family. It's
a big wireless happy family.
One of the points that I'm trying to get to is that maybe it's the data fusion piece that happens in the enterprise that becomes interesting. Whether it's BLE, whether it's LPWAN, whether it's private cellular, whether it's NextNav. The notion that the more data is better as it relates to if you're looking at a specific enterprise, say a casino, right? They've got a plethora of data already, right? When the elevator goes up, when the elevator goes down, the temperature in the rooms, is a door open, is a door closed, how many people are actually sitting on the chairs versus empty chairs. All that is data that's accessible through all the technologies that you guys have been talking about. What's missing is the data fusion piece. Like, how do we bring that in a time series way, right? So how do we bring people, places, and things data into one environment that helps the enterprise get to the outcome? And it could be compliance, it could be safety, but it could also be new experiences that are being generated, kind of like what we've got. The proto's not working, but hopefully we'll get that working later so you can see synthetic Scott Likens talk about the future of the world. Those types of experiences will come from this data that is being collected from your system. So do you see that happening? Because is it a commercial reason why we're not fusing these data sets together because people are creating still silos across these different technologies? Or what's going to unlock that value? Is it AI that's going to unlock that value and showing it through AI?
Like software and AI solving the problem is sort of an easy button for all of us to push. Yep. But the reality is, like, there is a physical constraint here, right? A lot of the technologies that we're talking about rely on physical hubs, physical cell towers, like real expensive infrastructure that we're relying on customers to build out and put around the world in order to make any of this possible. So I think that's why really at Hubble, one of the core values for us was just make it as rudimentary and simple as possible from an adaptation perspective, right? In order for people to adopt the technology, we don't want the barrier to entry to be a cell tower that you need to put up or a hub that you need to put 100 of these things around your warehouse. Just make it an open source software package that you can release that allows this to become ubiquitous. So really the onus is on all of us sitting up here to make that barrier to entry much lower from an infrastructure point of view. And then we can start to leverage all the benefits of software and AI and multimodal network, things like that.
I agree with that, with one caveat. I think having some set of standardized way of being able to collect the data and extract the data across these different networks would be really useful.
Yeah, and I think, and also at enterprises, there are different entities responsible for these different things. For example, safety. Worker safety is a responsibility of a operations person, while entertainment may be a responsibility of the CTO. So that disconnect is also there, so that the data that may be available in a single data, I mean, that's always been the challenge in many ways. Unified data platform, doesn't exist, and even is something like public safety that we're talking about, right? They want to track their employees when they go into a building to rescue somebody. They don't have a proper way to even track that person inside the building, and that's as simple as that. So I think that's one of the challenges that we face when we deal with enterprises, all of us.
Right, and I think it's not just for the kinds of things that we're talking about, but just overall when we go from sort of digital AI to physical AI, right? Because we have the best thing that any enterprise can do is to make sure that they have a consistent and conscious data management and data governance sort of workflow and pipeline, right? And in that all of their data is actually in a vector database, ready to be used by AI whenever needed. And that's where the data fusion happens. Because right now, people talk about ML ops and various things, but that data management, data governance is key,
Yeah.
because that's at the end of the day.
And you need some sort of anthology, right? You need
Yeah.
some sort of, maybe it's not standards on the, maybe it's a taxonomy, maybe it's not at the technology standards level, whether it's 3GPP or what you're doing with LPWAN or with Bluetooth SIG, but more, once that data is extracted, how do we create a common language, right? That everybody can understand and that can be part of, so that those algorithms that I was talking about earlier as it relates to a hospital or a hotel or an airport is something that is made available so that everybody can benefit.
And a lot of data is also protected under privacy, right? Location,
Yep.
for example, is a and phone numbers and
Yeah.
all that. So it's not easy to.
Haven't we thrown that out the window? Just, sorry.
I know. I think we're getting
touchy a topic?
slowly. We're getting comfortable with some of that.
This is true.
Tracking.
Our faces, for
yes, faces for sure. We wear Ray-Ban glasses with cameras now. 5 years ago, that was it was unheard of. So I think we are starting to get that, but organizations still have that responsibility to protect that data, and that becomes another challenge. Like when we are trying to data fuse data from different sources, like clearing up all of that is also a problem.
Well, I think Neville nailed it, the IT/OT problem. Like we did a project with a major auto importer last year where they don't own the port, but they can't even scan the car or do the 50 meg update to the software, because it's basically, right, a computer on wheels at this point, right? And, so we had won this deal, and it took 8-9 months to actually deploy it, because you had the GM of the operations, you had the IT guy on site, you had the international owner of it, and they all desperately wanted it, but they could never sort of sync up, on the IT/OT thing, and then once they got it, they were like, well, why didn't we do this last year? And I just think there's a real big cultural and organizational divide on the IT side.
Totally agree. And I think one of the future challenges to adoption of these networks is going to be if you can't bring IT and OT together into a single instantiation within the organization, I think there's always going to be this barrier to deployment.
Want to open it up? We got 10 minutes left. Want to open it up to the audience. Does anybody have any questions before I ask the question about the future? Anybody? Does this spur any questions? Does anybody want to pipe up? We've got this amazing set of knowledge here. Yeah, go ahead, Jason.
So I'm part of the. Sure, thanks. I'm part of the hardware design team here at PwC, and so
We have a hardware design team.
We
at
do,
PwC?
in fact, and and a lot of things that we're concerned with, like you can't have IoT without the things. I think one of the panelists yesterday morning said you can't just drive around your data. Your car, you need the car to provide the data. So a lot of the things we're concerned about early in product design is the size of the antenna. Like every one of these devices needs some type of antenna. Could you talk about a little bit, Alan, the requirements of or what a personal cellular or private cellular network, does that enable some of the devices to get smaller? Because a lot of times, like cellular antennas are what's driving the size of a product.
Wow, well, I own the whole global ecosystem for Sigfox, whether from a semiconductor to a device to a cloud. Plus, we deal with it. It's actually, I think, easier in cellular because I would say, let me take a step back. One of the biggest problems on the device side is everybody thinks that their little special child needs a special thing, okay? And I still remember signing the first of 6 or 7 logistics companies at Sigfox. And after the first one, I'm thinking, thank God we have a really good tracker now. We never have to do another one. And everyone's like, no, I need this 2% difference in mind. And I think the trick with these projects is getting something off the shelf that does 80% of what you need, get smarter, and then decide, okay, what kind of actual antenna, compute, even like the enclosure packaging. But what we're finding in private cellular is very different in that if you think about partners like Zebra, like Honeywell, like for scanners or for ruggedized tablets, they've solved that problem for you. okay, for your enterprise or industrial environment. So it's actually been less of an issue in private cellular than it was more in an LPWAN space. But we're at the point now, if you look at the size of the LoRa ecosystem, I mean, it's absolutely massive. I mean, you better have a really good reason to do your own little special thing.
We kind of feel like we've been part of the LoRa ecosystem for a while, so we don't want the word to get out too much at PwC, but it is probably one of the most
And BLE, of course, but Bluetooth in general, I mean.
undervalued aspects of the OT world that we're living in, right?
But this is where
Everybody knows Bluetooth.
But this is where you have to combine networks, right?
Yep.
This is where you can't just rely on a single cell. You can't just say, okay, we are going to deploy a private wireless cellular network. It may not do everything economically. It may not be able to collect sensor data economically because you want that Bluetooth LE device sensor talking to a hub that's then connected to your cellular network wirelessly so that you can pull all that data back. Putting in a 5G device into the network to collect data might not be the economical way to go because you may not be able to power it economically either.
Exactly.
But one other thing I would add, I have some colleagues that work in the device engineering side of things, and they're saying, our engineers really don't understand the connectivity as well. I mean, they know Bluetooth, maybe they know Wi-Fi, but when it comes to LoRaWAN or cellular, they're not as comfortable with those. So I think educating them, giving them various toolkits to be able to work with that.
I've seen engineers try to put antennas on the backside of metal plates. And then, your stuff.
Well, that's how you innovate,
stuff
right? You
doesn't
might
work.
discover something completely new, right? When you put things together that don't go together, Alan, that's how you create,
Have you heard of-
That's right.
Have you heard of a guy named Faraday? I mean, it's.
He had a little cage.
No, when the IoT industry started, the cellular IoT industry, that was one of the problems that we were facing, and we had to have education sessions for the developers to be able to, build this in a more economic way and design and so on. So we had a whole program at Verizon many years ago to do that. But I think the industry is growing, so it needs more education. Like as you said.
A couple approaches to take there, right? You either get the community smarter on how to work with your protocol and your technology, or you can, work on making your technology kind of meet the needs of what is off the shelf, right? So one of the things that we've worked really hard on is get very basic on the chip side. No antenna, special antenna requirement, off the shelf BLE chip. Our current generation of satellites, all it needs is a certain output power, which you can get with a power amplifier. And that's all you need for global connectivity with a Bluetooth device, right? So no hardware in the middle of that.
Well, what's interesting is when you bring things together that don't normally go together, or you use something that was designed to do one thing for something completely different. In the Bluetooth world, when Stillman Bradish and I started Wireless Registry years ago, we thought about all these signals that are around us and why aren't we capturing them, why aren't we leveraging them? Well, everybody's kind of woken up to that, including the letter agencies from the different governments around the world. But at the end of the day, it's a technology that's there, that's pervasive, that could be used for a lot of different things. In our last question, which is around predictions, where do you see that type of innovation happening because of the unlocking of these silos, because of potentially all of you guys' technology coming together to solve problems for enterprise, but also for society as a whole? Do you have some predictions, like where we're going to be?
5G O-RAN. I'm going to throw that.
5G Open
In
RAN.
addition to managed services.
5G Open
So
RAN.
5G
okay.
O-RAN, if you're not familiar
Chago
with it.
just joined.
Because
just joined
the U.S.
Vodafone,
government
right?
alone right now has decided 5G O-RAN is the 5G standard. They are the biggest enterprise in the world. They are in the middle of spending $1.5 billion. They just awarded another $400 million a month ago, and the third phase now is like another 400.
Everybody's
It's more on the
Googling
software
O-RAN
stack.
right now, Alan.
And the users.
Except that there are only about 2 companies that have made any money out of
no,
ORAN
there's
today.
For now.
But I'm telling you, they're developing the domestic capability, both software and hardware. Our friends at Intel are very well positioned with that, and we work closely with FlexRAN as part of our 5G O-RAN solution. But
Don't forget Rakuten.
of course. But seriously, 5G O-RAN, and long term, I think it's the most cost-effective and higher capacity approach for enterprise as well.
Predictions?
Yeah, well, I think this year, starting with this year, we're going to see the first steps of the convergence. We're already seeing, starting with the devices supporting single radio, We're already seeing multi-radio devices connecting to different radio networks and architectures. Towards
Well, even Sigfox and LoRa, right?
exactly, there are devices like that as well, and there are going to be more of those with like Wi-Fi, Bluetooth, and we're going to see the first steps of convergence through that, and that'll move towards further convergence in the subsequent years.
Yeah, I think I'll second that one, but I might put a bit of wishful thinking and maybe a kind of New Year's resolution in there as well, which is that this community does the work of building that convergence and bridging that gap, right? I think enterprises are sick of that patchwork exercise where they have the onus of connecting all these disparate networks. I believe that it's on us to really bridge those divides, make a multimodal device or multimodal protocol capabilities.
Us includes PwC too, I'm sure.
Of course.
Yeah, and I totally agree with that. I think that's certainly something that we're going to see being driven into the market in 25. I think, of course, 5G and more research and development on 6G. I think these conversations around things like ambient IoT, whether it's in cellular, whether it's in Bluetooth or other areas using other wireless technologies, need to come together. Like the networks need to come together. I think you're going to see over the next couple of years, some real new innovation in the enterprise space around Bluetooth. And that's going to drive the CAGR way beyond 20%.
For sure. Azita?
So two predictions. One is for, when it comes to frontier models, we're running out of data, right? The internet corpus was just so much. And of course, it's growing, but it's still kind of limited. So we have to get into the physical data from physical world. So those frontier models will need a lot of data that we just talked about coming from various devices connected via various ways. So it's not just enough to have synthetic data. It has to be real physical data coming in. So that will be a big drive from the frontier models that we'll see this year. And then the sort of related to that, I think in order to make that whole, especially the inferencing part of AI more efficient, we're going to see not just the edge AI on the device or not just the central cloud working on that, but along the way, different parts of the network can participate and provide the infrastructure for the AI to sit on top in an efficient way.
Sanjita, last word?
Last word. I think we, for the past few years, we have seen from a macro network perspective, as of course indoor we have all these different solutions. None of them are appropriate or scalable from an outdoor perspective, except maybe satellite, right? And that has a space, of course. But macro cellular networks will continue to develop, and the need for more spectrum is here, right? We don't have spectrum available, especially for coverage perspective. And the industry has focused on speed a lot. I think we need to go back into coverage. We've started to see performance, and of course, being able to use networks for multiple purposes.
Right.
And one of them is location, especially standardized. That all it can go into devices, right? Because for consumer, scale is important, and standards are important, and that's why 3GPP based technologies are important from a consumer perspective, and that flows into enterprise as well. So I believe that realization will be more, and we are looking forward to that.
It's super exciting. Well, from PwC's perspective, I joke. Some of you close your ears, particularly you marketing people, that PwC stands for private wireless communication in my world. But we are seeing a huge opportunity in the enterprise space as it relates to everything that we talked. And I really appreciate you guys spending the time here. We're here. All of these folks are available for interactions. We also have a great story to tell about PwC, starting with the device and design engineering, all the way through to the data analytics. When I was talking about signal frame and signal graph, it goes all the way to the data analytics space. So please stay here and mingle. We have mimosas. Did I mention that we have mimosas? And we have also Bloody Marys for anyone to help help the conversation. So, guys, thank you so much for being here and participating in this wonderful panel. Thank you.